Okay, so had to restart it there. All right. Okay, so what I'm going to do, I'm going to do a couple problems out of section 5.4. It's the word problems associated with systems of equations. They're going to sound very familiar to what we did before. So before we were learning how to deal with word problems just using one variable. Now we're going to use two variables. So a lot of these things will set up a little bit easier. Let's see if you agree with me. All right. I think I'm going to not write the whole problem down. I'm going to, you should be able to access the book, but maybe I'll type them in to Canvas so you can just see it in case you can't see the book, but you should be able to see the book. So this one says the sum of two numbers is negative 30. So I'm going to call the two numbers X and Y because there's no reason to call them something else. You can call them whatever the hell you want to. W and J, you can call them, whatever. You can call them box and triangle, to be honest. Let's not do that. Maybe next time. It's negative 30. One number is 5 times the other. One number is 5 times the other. So here's one equation, two equations. So in these word problems, you will see two distinct relationships between the variables. Which method seems to make the most sense here? I already have an equation solved for X, so then I can use this in here. So substitution seems to make the most sense. So let's go ahead and do that. Let me rewrite number one using this information in that equation. So X, which is 5y, plus y equals negative 30. And now this is nice. I'm just going to go a little quickly through here. Blah, blah, blah. Y is negative 5. Kick butt. Right? So then what's X? Well, X is 5 times y. So X is negative 25. So you can write the answer as negative 25, negative 5. X comma y. That would be the point where these two lines would meet if you graph them. Okay, and graphical method is an option, but it's very difficult to do some of these by hand and see exactly where they cross. So in general, we don't normally fall back to graphing. There are some, there's some in the future that might be easier to do graphically, but we're not going to worry about that right now. So again, you can pause it. Okay. So let's try one that's not, that was a very basic, that was a very basic type of word problem. That's just one step away from equations. It's almost like somebody reading the equations, so we just have to write them down. Let's try one that's a little bit different. Let's see, what you got, Jeff? Ooh, freaky. Okay. So 205. So this is still section 5.4, number 205. It's all about Troy and Lisa. Why we care about them, I don't know, but you better, because we're going to do this right now. They were shopping for school supplies back in the day when you actually needed to bring stuff to school. Each purchased different quantities of the same notebook and thumb drive. So notebooks and thumb drives. Troy bought 4 notebooks and 5 thumb drives. Lisa bought 2 notebooks and 3 thumb drives. So it says find the cost of each notebook and each thumb drive because it tells me how much money total it was. So the variables have nothing to do with Troy and Lisa. The question asks the cost of each thing, notebook and thumb drive. So I want my variables to mean cost of a notebook and a thumb drive. You guys know what thumb drives are, right? You should, right? Called flash drives, USB drives. Anyway, you know. All right. So here's what it says. Troy bought 4 notebooks and 5 thumb drives. Okay, so first I got to give them variables. It kind of makes sense to call notebooks N, and I can call thumb drive capital T. That should not be too dangerous for me to use capital T. It's not going to look like a plus sign or something. So what did Troy do? Bought 4 notebooks and 5 thumb drives. 4 notebooks and 5 thumb drives, and he paid a total of $116. Yeah. Lisa bought 2 notebooks, right? Because she's like, screw notes, and 3 thumb drives for $68. Okay. Now, the way this is set up, you could use substitution, but again, any letter you solve for is going to create fractions. Can everybody see that? Anything I try to solve for, I'm going to have to divide by something, right? Maybe I'll show you, maybe, I'll think about it. The way it's set up is really good for elimination method. That's the one that I did the last video on. This is my favorite method because I can just directly kill things. I'm going to leave this first dude alone because notice these would suck, right? To make these the same number, I'd have to make them both 15. I'd have to change both. This one, again, like the LCD idea, I can make 2 become 4. In fact, I want to make it become -4. So I want to multiply by -2 because I want what's here to kill each other, right? So if I multiply 2 times -2, -4n, 3 times -2, -6t, 68 times -2, shit, Jeff, what do you get? 136? All right, let's all hope that's the right answer. Yes, it is. All right. So, does everybody see that? If I add them the way they are, nothing cancels. So why would you do that? You're going to make a third very difficult equation. Why would you do that? I want to kill a letter so that I have a much easier equation. So these 2 become the same. I have to multiply by negatives so that they become opposites, so that when I add them together, they cancel. And 5t minus 6t is -t. 116 minus 136 is -20. So then the cost of a thumb drive is $20. That's pretty good. It must be, I don't know, not that huge of a thumb drive, but oh well. So I know the thumb drive costs $20. Now, how much does a notebook cost? All right, well, I can pick either one of these. This one's got smaller numbers, so why the hell not use number 2? Let me see if green's going to work. I don't even think it shows up differently. Does that show up differently? I guess I'll find out in a minute. 2n plus 3t, t is 20, become a 20, equals 68. 2n plus 60 minus 60, 2n equals 8, n equals 4. Bam! There's my tissues, in case I need them. It's actually my office mate's tissues, but they're my tissues then. All right, sorry. $4 for notebook and $20 for thumb drive. Thumb equals $20. That's right. We're getting body parts off the black market. Notebook is $4. All right. And you can check it when you plug it in. 80. I'm sorry. You can do it, Jeff. 16 plus 100 is 116. Sweet. Okay. So you can pause it. Okay. And again, for these word problems, it's definitely a lot less important to write them as a point. That actually makes less sense. But mathematically, the 2 equations, if I graph them, they will meet at the point. Okay, let me see how much time I've got here. Maybe I'll do one more. Oh, maybe I can fit in 2 more. Because, I mean, if you're over it, you can just stop the video. It's crazy. Let's see. Where's it? Oh, here we go. Beautiful. Some geometric problems. You're like, yay. Okay, this is perfect. So let me talk about this real quick. Complementary. I think it's actually, yeah, I always misspell that. I make it become like a compliment, like, oh, that's some nice shoes. But it's a different word. Complementary angles add to 90 degrees. So if I had an angle 40 degrees and an angle 50 degrees, they are complementary. Okay, that's complementary. Supplementary angles add to 180 degrees. So if I had an angle that was 120 degrees and I had an angle that was 60 degrees, those are supplementary. Notice alphabetical order grows from 90 to 180. Complementary 90, supplementary 180. Oh yeah. Hopefully it sounds vaguely familiar. Pause. Okay. So this is a problem number, which one were you looking at, Jeff? I don't remember. Yeah, 214. Sure, why not? Still in 5-4. The difference of two complementary angles. Okay, they tell me they're complementary, so I've got two angles. Let me call them A and B. The first thing they tell me is the difference of two complementary angles. Stop. That's an equation. The two angles are complementary. CS. C is 90, S is 180. Complementary, add to be 90. I like it. Okay. But now in the process of that, the difference of them is 17 degrees. All right, this one's almost too easy, so I apologize. It's going to come out gross. They must have meant for this to come out a little gross. Yep, all right. So, what method works the best here? You could use substitution. But why would you? Look at this completely beautiful. This is why it's so easy. These want to die. They just want to die. We're what do you call it? Oh, I don't know words. We're okay with that. We want them to have a nice life. They're done. Bees have had a long life. Not bees. That's terrible. We need bees. All right, I'll stop. Anyway, these guys want to die. Let them die. Add these together. A plus A is 2A. These kill each other. I'm going a little crazy. 90 and 17 is 107. Divide by 2. What is that, Jeff? I don't know. 53.5. Sounds great, right? Sure. Don't forget units, degrees. So then what's B? Angle A is that. Angle B has got to be 90 minus A, right? So 90 minus 53.5 would be what, Jeff? 36.5 degrees. God, I hope that's right. Yeah, it looks about right. Okay. One more, I think, before I go completely loopy. That's a geometric problem. I like it. Okay. All right, let's see what else they got for me. One more. Oh yeah. You know you love them, and they're back. They're back just for you. Yeah, let's look at 233. That's pretty funky. It says a commercial jet can fly 868 miles in 2 hours with a tailwind, but only 792 miles in 2 hours into a headwind. Find the speed of the jet in still air and the speed of the wind. All right, so speed of jet, speed of wind. So this is just like when you're at the airport. You got the, what do you call them, conveyor belt thing, right? What do you call them, the walkway? You know what I'm talking about, where you get on them, you're like, I'm bionic. So if you walk with it, you go faster. If you walk against it, you can actually walk in place and pretend like you know how to moonwalk or something. So it's the plane, if it's flying into the wind, it's going to go slower. If it's flying with the wind, it's going to go faster. So let's call the speed of the jet J. Wow, Jeff. And the speed of the wind W. Jeff Waller. All right, sweet. Blah, blah, blah. So now we've got two situations. So just like we've done before, distance equals rate times time. So I got into the wind, against the wind, and then with the wind. Where are you at, Jet? It could fly 868 miles in 2 hours with the tailwind. Okay, so 868 miles in 2 hours. Not a, what was that one, Jeff? Slow it down, buddy. with a tailwind. So with the wind. So 868 in 2 hours. And it can fly. You can do it, buddy. Only 792 miles in 2 hours. Right, with a what do you call it? Yeah, against the wind. I like it. So into the wind, it's going to be going as fast as it is minus how fast the wind is going. And with the wind, it's going to be going as fast as it is like that. Okay, so let me stop for a minute. This is a little bit different than we're used to. We normally keep something open, but now notice the difference here. Each row is going to represent an equation. So can you see the first row is the equation 792 equals rate times time. So 2 times J minus W. My God, Jeff. You think you can make your own letters in your own name. And the second equation is going to be distance, 868, equals rate times time. So 2 times J plus W. Now, I really hope you guys can see this. Stupid 2 is kind of like, if only that 2 wasn't there. Now, to be honest, well, let's just do it this way. All right, I'm not going to make it too freaky. So if I did do, we'll distribute that 2. I could divide the 2 is what I was going to say, but if I distribute the 2, it's still a set up nice. You guys see how it's set up nice? You're like, no. You see how the winds just want to kill each other, right? And I'm really sorry, sort of, if you just don't like all the death in my math classes. But yeah, it's kind of, Game of Thrones-ish. So the winds kill each other. I'm going to add these together now because these do cancel. I'm never going to add things together if they don't. 1660. Is that right? Sure. And then 2J and 2J is 4J. And of course, the negative 2W, 2W canceled. Divide by 4. I get J is 415. How's that sound? I think it's right. So the speed of the jet is 415. Now let's see what our units are. Probably miles an hour. Miles an hour, yeah. Because this was miles and this was hours. So this would be miles per hour. And the wind, ooh, I got excited. If I plug this in, let's plug it into number 2. 868 equals 2 times J plus W. 868 equals 2 times 415 plus W. 868 equals 830 plus 2W minus 830. Okay, I don't have to, do I have to give a play-by-play? 38 equals 2W, so W equals 19. Man, I really hope that's right. I don't know. Doot, doot, doot. Yeah, looks good. All right. So that is section 5.4. And to be really honest, I think section, well, yeah. Did I sign? Yep, I sure did, because I'm evil. All right, so tomorrow I'll post some stuff about 5.5. It's more word problems. It's very familiar to stuff we've done before. It's like the kids and the adults and the ticket costs and all that kind of business. I'm pretty much spent right now. I got to make some statistics videos. Anyway, so shoot me an email. Let me know if you need some help. I still need to, I feel like there's something else I need to do. I got to check the canvas. Tomorrow I'll post another video. As soon as I figure out exactly how I'm going to work assessments, I will let you know. If you are concerned, again, just email me or something. Obviously, don't call my office. I might not be allowed back on campus starting tomorrow. Yeah, so these are going to look kind of different. I'm going to do it at my house, probably point the sucker down my table, and then just, you're going to see my hands. That's it. You're not going to see me. Some of you guys are like, thank God. Okay. All right. That's enough for this. Boop.